I'm Steve Lippert from the Cloud Services Marketing team at Juniper Networks. I'm the host for today's webinar on 3 simple yet powerful strategies to remove operational complexity in the cloud. Before we begin, I have a few housekeeping points. At the bottom of your screen, there are multiple application widgets that you can use. All of these are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can also expand the slide area or maximize its full screen by clicking on the arrows in the top right-hand corner. If you have any questions during the webcast, you can submit them through the Q&A widget. We'll try to answer all of these during the webcast, but if a longer answer is needed or we run out of time, then they'll be answered over email later. A copy of the presentation and other help materials are available in the resource list, and the webcast is being streamed through your computer, so there's no need to dial in to a phone line. For the best audio quality, please make sure your speakers or headsets are turned on and the volume is turned up so you can hear the presenters properly. Some networks can cause slides to advance more slowly than others. If your slides are behind, refresh your browser and they should catch up. If you find additional answers to some common technical questions in the help widget at the bottom of your screen as well. Finally, an on-demand version of this webcast is available approximately 1 day after the webcast, and you'll be able to access that via the same link as the main invitation. I would now like to introduce the other presenters and the agenda for this webinar today. After the introductions, I'll start us off with some quick context to the challenges facing cloud providers in today's technology and business landscape. Ben Williams will cover the main topic of 3 simple yet powerful strategies to remove operational complexity in the cloud. Ben's thoughts on this topic have been honed from his many years working with cloud providers, both during his time at Juniper, but also from his time working within multiple service providers. Ben, would you like to briefly introduce yourself?
Hi, I'm Ben Williams, Senior Systems Engineer at Juniper Networks and currently working in the Specialist Systems Engineering team.
Thanks, Ben. Following on from Ben, we'll be joined by Kevin Fivich, the CEO and founder of CloudSeeds. Kevin will share some of his experiences, how CloudSeeds help their customers to build highly scalable and automated infrastructure using a mixture of open source cloud computing components. Kevin, would you like to briefly introduce yourself as well?
Yeah. Hi, I'm Kevin Fivich, founder and CEO of CloudSeeds, and pretty excited to share some of our experiences with Juniper today.
Thanks, Kevin. After Kevin's finished, we'll open up the webinar to questions and answer. Whatever part you play in the often complex value chain around the cloud, at the end it all comes down to providing services to enterprise customers. They are everybody's eventual customer. So I'd like to start with thinking about their IT requirements. At Juniper, we believe that enterprises are now firmly within a new multi-cloud era. Over the past decade, we have seen the rise of the smartphone, which in my view has really unleashed the cloud. It was a catalyst to deliver applications from the cloud so that you can access information from multiple devices and collaborate easily with others. Personally speaking, the first cloud app I really used was contact syncing from my smartphone to the Outlook client and webmail. The simplicity of an app in the cloud, which took away many manual sync processes, was something that I valued. But it also gave me an early look into where we are today. Apps are in the cloud. You can work from any device. And they're so simple that they're almost magical. As you'll know, all of this is delivered from a complex IT environment. Some applications are still run from a private or hosted data center, especially where performance or data security are critical. But we're in the middle of a massive shift from private facilities to public cloud providers. Why is this? There are some cost benefits for some businesses, but for many, it is really about removing complexity from their business by letting others do much of the heavy lifting from the underlying infrastructure. In a similar way, we see many businesses embrace software as a service. You're buying in the software, so why build your own infrastructure to run a mail server, Oracle, or the expenses application? Instead, just pay per user per month for everything in a nice and predictable way. But with this new multi-cloud environment, it is difficult to manage the connectivity and security across the complex infrastructure, which must connect all of an enterprise's offices, remote workers, private clouds, public clouds, and SaaS providers. This complex environment needs experts to help design and operate it. That's where we see cloud service providers playing a fundamental role. Cloud service providers are not typically building a public cloud or even SaaS applications, but they do play multiple roles to help their customers architect, design, build, and manage a multi-cloud environment. That's a wide toolkit for any business, maybe too wide for many. Businesses are moving to the cloud because it's a great customer experience, and that's what you need to focus on too. How can you use your technical skills to deliver a multi-cloud experience that delights your customers? I believe that service providers in this area will often focus upon 2 or 3 areas where they can excel, and then may partner with others to fill in the gaps. For example, you may have great customer relationships in a specific geography or vertical, with expertise in application design. In that case, you may need to partner with a provider for managed hosting or connectivity. Similarly, you may have deep expertise in security and need to partner with another provider around the connectivity requirements. Wherever your expertise lies, it's important to excel at it. There is one word for me that summarizes all of these challenges, and that word is complexity. That's why I'd now like to hand over to Ben Williams, who will talk about 3 simple yet powerful strategies to remove operational complexity in the.
Yeah, thanks, Steve. So as Steve's outlined, cloud operators are increasingly playing the role of service aggregators for their customers. So what this actually means is dealing with the operational complexity and the risk on their behalf, but they're still required to provide the service experience that their customers expect. So what I want to first do before we talk about the strategies is just outline and highlight some of the top contributors to this complexity and what we're doing in terms of the software and technology that Juniper are delivering to try and remove some of that complexity. So if we take a look at the 5 major contributors to complexity in this environment, Steve's already touched on public cloud and software as a service consumption, and these services are all about ease of use and self-service. So that's what's largely driving expectations in the market for end users about how the services should be presented and consumed. But for cloud operators, aggregating or blending these services as part of a wider service, it means managing a highly distributed and dynamic environment. And each of those environments has its own set of capabilities, operator interfaces, and APIs. And all of those need to be presented seamlessly to the end customer. In addition to that, there's also a need to provide different types of consumption models. So that could be infrastructure, platform, and now container as a service. Ultimately, this drives some platform diversity in terms of multiple flavors of hypervisors, containers, and all of this is underpinned by networking and security devices that need to enable and not restrict self-service and on-demand consumption. So even today, we do see automation being embraced by cloud operations teams, and it is practiced widely on the infrastructure. But we often see creation and delivery times for services hampered by manual tasks. So you get disconnected workflows between operating domains, and more often than not, the bottleneck occurs between platform teams who have embraced that automation. They're used to spinning up resources on demand very quickly, and then the traditional networking and security operations teams. And they're required to provide connectivity, strict compliance, and security controls across a distributed environment which actually contains different types of infrastructure and spans operational boundaries. So, this is where the complexity really comes in. And then once that service is delivered, it's operational, security and service uptime needs to be maintained. So that requires monitoring of threats, service impacting issues with, across multiple layers of infrastructure and software. So you need to be able to troubleshoot across these layers effectively and respond to security events or faults when they occur. So really here the pressure is on the cloud operators to deliver that security without impacting the speed at which their customers can do business.
So here at Juniper, we've been thinking about how to address these challenges and simplify operations for our customers using automation. And we've created software and tooling for intent-driven solutions. So intent-driven software focuses on what operators or developers want as an outcome rather than how to achieve it. So you can think of that as providing high-level business policy, which is the what, without the need to implement or even understand the low-level configuration details needed to achieve it. So instead, we're using software to automatically translate the intent, or the what, into the low-level configuration and carry out those steps to implement it. So this is a particularly powerful approach for provisioning, but also for service assurance. So from a provisioning perspective, you could say, specify how departments or application tiers should be able to communicate for a certain type of application, and the configuration to achieve that would be implemented, and future workloads provisioned into those departments or application tiers would inherit the same behavior. Once a service or a state is implemented, then that desired state can be continuously evaluated. So necessary actions could be taken to automatically maintain the optimal operating state of that deployment. But the foundation of this is being able to get information about available resources, about the health of the cloud, traffic flows from across the entire cloud infrastructure. So servers, network devices, security devices, software and application components, and getting that in real time to be in a position to be able to act on it if required. Ultimately, this generates a lot of data in this phase, so you need to use machines to analyze it and to provide the fastest result and enable faster root cause identification. So an example of that could be if a host NIC is randomly dropping packets, that could impact numerous applications and virtual machines that are sitting on the host. It would take a human probably more time to identify that than a machine. And adding machine learning here also provides some additional benefits. As a cloud operator, you may not know the behavior of a customer application. So, for example, if a customer is delivering an online retail application, which is busier than normal every Tuesday night, then you might expect traffic resource and utilization to be higher during this time. So if you set static monitoring thresholds against an average, then that would mean receiving alerts that ultimately wasting operational effort and time troubleshooting a problem that doesn't exist. So using machine learning to learn about the behavior of the environment and baseline it based on that, then there's no need to set arbitrary thresholds. And when the normal behavior in the environment is known, it's possible to generate alerts if the behavior deviates from what has been learned. From a security standpoint, it's possible to leverage AI and machine learning to learn the expected behavior of malware. This provides a much greater chance of identifying new threats because it's being judged on the way it behaves and not on a static comparison to existing malware. In each case, you're in a position to take action much faster and potentially avoid a breach or service outage. And it's at this point where it's possible to use automation to take the actions required to address the problem. So if we look at an example of operations, that could be under normal operation, scheduling of virtual machines onto a particular host hasn't caused any problems, but the application workload has increased, which is for a certain subset of those virtual machines, and that's generating high CPU load on the physical host, or potentially high network I/O, causing packets to be dropped at the NIC or switchport level. So actually, you could use automation to redistribute the virtual machines to alleviate that problem once you've identified it, or in a security standpoint, quarantine a virtual machine if a certain level of compliance is not being met. So this is a continuous process of evaluation and optimization and can actually be fully autonomous to operator intervention. And going forwards, you're going to see evidence of this approach across each of the strategy areas that I'm going to discuss. So with that in mind, these are the three simple strategies for reducing operational complexity and the steps to leveraging the intent-driven cloud. So orchestration is a coordinated set of automated tasks, and they're done in the right order to achieve a desired workflow or outcome. In a multi-cloud environment, orchestration needs to cover automated tasks that span network and operational boundaries. And as we've already discussed, within that environment, there's a need to continually analyze all the interdependencies in the infrastructure that exists and compare the current operational state of services to the desired state. And what that actually does is enables you to quickly identify changes in behavior. And by changes in behavior, what I'm talking about are risk to security or to service uptime. Now, security or secure sounds like a rather obvious choice, but in the context of multi-cloud, it's more about addressing the complexity that comes with managing multiple different environments and multiple vendors. So this is about simplifying operations with consistent security, embedded into a service, but also adaptive and able to identify new threats. And also streamlined, so that should enable cloud operators to be proactive instead of reactive, and enable, not stifle, their customers' ability to do business. On the left, some of the key areas that we should think about when we apply these three strategies are being open to integration into a wider functional stack, and
that is essential, and I'm going to discuss how at Juniper we're applying automation across all of these areas to reduce downtime and assure and secure services. But additionally, we believe that the appropriate technology and tooling should be open and integrate to control multi-vendor systems and enable end-to-end operations and ensure that cloud operators can remain agile. So going a bit deeper, we're going to talk about the guiding principles behind those strategies, and you'll see evidence of these in the technology that I'm going to discuss in later slides. But at the top of the list, we talk about decoupling hardware and software. And in this instance, we're talking about using an overlay service that can remove service state or service configuration from the underlying hardware. And that can remove the network as being a bottleneck to service provisioning and actually allow the network to be scaled for performance. Ultimately, this allows an operator to get services to market quicker. Now, the central component of the cloud is still the network. It connects servers and endpoints together to create applications and services and actually provides a gateway through which they can be consumed. To run the cloud at scale, you do need the right scale and performance in that underlying network, but you also need the ability to support open architectures to make sure you can deliver multi-vendor solutions. So in that case, all the elements should be accessed programmatically using open standard APIs. And that actually makes the hardware features still relevant, but operations at the CLI level are removed, and that ultimately avoids lock-in and fosters innovation for integration of new technologies and tools. From an automation perspective, we're working towards the goal of orchestration. So the focus here should be on automating the tasks that provide the most value and make the most sense. So here would be repeatable tasks that are quite common, but also provide the best impact in terms of removing some of the manual work. So it may not be possible to actually automate a whole business workflow in a short space of time, but analysing that workflow and breaking it up into the tasks which can give you the most gain is the best strategy there. But ultimately, applying automation correctly reduces operational overhead, not just for delivery, but because it's consistent, it removes human error. So you don't spend time troubleshooting a typo or copy and paste error that can be possible if you're doing it manually. From a tools perspective, we're advocating the use of open source frameworks and programming languages to automate network operations. And this is something that is going on today. Actually, from a positive standpoint, provides a vendor-agnostic and consistent approach, the ability to plug in multi-vendor components into a framework in a modular way and reduce the number of tools in use. So moreover, the use of open APIs to extract away the hardware or vendor-specific syntax can also simplify operations. Lastly, adopting the mentality to keep changing, so the continuous analysis and optimization of processes and procedures will drive the necessary culture to embrace intent-based cloud operations. So let's get into the detail of orchestration. So what we talked about at the start of the call was the fact that cloud operators are service aggregators. And this is about blending private cloud services with SaaS and public cloud to deliver value services to their customers. And there's a number of challenges in delivering that across a multi-cloud environment. If you look at the diagram, at the top level you've got lots of different types of workloads. So that could be bare metal servers, virtual machines, containers and public cloud instances. And typically at this layer, operations are largely automated. It's fairly inherent at compute and virtualization level. And the tooling's there to deliver that. But what happens is that's driving pressure onto the network and security operations, where we still see a lot of the workflows are quite manual, and the operations teams work separately across network and security, and that actually slows down the onboarding of either new infrastructure or the delivery of customer services. In some cases, we've actually seen security being sacrificed at the expense of agility or the expense of speed. Basically having network access for all tenants on a switch, for example, so that the virtual machines can be placed anywhere. So as I said, network and security are often applied separately, and if you then look at the number of touch points that someone has to go to deliver a multi-cloud service, that actually amplifies the problems or the effects of manual operations delivering across a multi-cloud environment. And in a lot of cases, some of these operations and workflows are domain or vendor-centric. So again, there's a lot of disjointed disconnect between delivery there. So those touch points at the bottom actually create dependencies for the end-to-end service delivery. And each of those touch points mean different teams, sometimes different people within a team, but also different tools and interfaces and APIs. So again, this is all leading to extended delivery times for getting a service successfully deployed and operational across multi-cloud environments. There's different operating domains, and at each of these touch points make it very challenging for operations to deliver consistent security. And this is something we'll be talking about. You've got a distributed environment, dynamic workloads, so how can you apply a policy that's consistent and secure, but how can you also maintain the ability to identify and respond to security events or incidents of compromise across this distributed environment? So we examine the life cycle of service delivery in this environment in the center. You've got different types of infrastructure, so compute, storage, networking, multiple private data centers and connections to the public cloud. So different components, different environments, all with dependencies on each other to be able to deliver an end-to-end service. Contrail has the ability to dynamically configure network and security independently of the underlying hardware. So the network characteristics and security controls that you define are attached to virtual resources and can be extended to bare metal workloads. So we're using a scalable, consistent control plane to connect and microsegment these different workloads. And actually, we're supporting multiple hypervisors in this case, as well as containers and bare metal servers. So Contrail isn't a new product, and you may have heard of it already. It is deployed in a number of production customers, different use cases, infrastructure as a service, platform as a service, and in enterprise data centers as well. So we're extending Contrail's capability to support the lifecycle management and configuration of underlying switching fabrics and compute. So this will also extend to multi-vendor fabrics using a consistent and scalable control plane, and we will allow discovery of public cloud resources, so for example VPC in AWS, and expose workflows for extending network and security between private data centers and the public cloud. So what we're doing here is minimizing touch points and interfaces for this end-to-end service delivery and allow it to be orchestrated through API-driven workflows for end-to-end automation. The ability to do this, if you look in the top left-hand corner, and connect different types of workloads ensures that cloud operators have a very consistent networking and security implementation regardless of the types of resources that they're connecting, and by default you can isolate that in full. So this is fully API driven, so it's automation from the ground up, and we've included rich analytics which can communicate the real-time state and do trend analysis so we can understand across the environments what's happening at any given time and predict and be proactive about changes in behavior. If you look at the second box, blue box at the top, we've also got the ability to what we call service chain. So we can take multiple different vendor functions that are virtualized or physical and include them in services, so things like firewalls and load balancers. And security on the far right is actually embedded in this. So you're centrally defining a policy and how it should be applied to a certain application environment, and that's enforced in a distributed way across this environment. And it moves dynamically as the resources are created. So this makes the security portable in the sense that it can be used consistently across multiple environments, which obviously minimizes operational overhead and increases security. And what we're actually doing here is extracting that policy to focus more on information about the workloads themselves as opposed to typical networking constructs like IP addresses or VLANs, such that it can be portable. And that allows you to define a policy once and use it across different infrastructure, so you're reducing policy admin and operational overhead at the same time. I wanted to highlight one specific use case where cloud operators are assisting their customers in being able to adopt containerization and embed containerization in their application development or their services. And in this case, what we're seeing is that cloud operators are using their underlying virtual infrastructure to expose containerized environment to the end user or to their customers on a per-tenant basis. And obviously this adds some additional complexity because we've got another multi-layer environment. And what we can actually do with Contrail is offer a common SDN deployment. So that enables the dynamic networking and security that I talked about to be applied across both layers. So for example, if cloud operators operating OpenStack at the Vim layer in the virtual infrastructure and then exposing containers scheduled with Kubernetes at the tenant level. And so we're greatly simplifying manageability by providing a common Contrail deployment across these layers. Given that there are dependencies at multi-layers within this infrastructure and across multiple operating domains, I want to talk more about analytics. There are some challenges that exist in first visualizing and then analyzing data in these cloud operating environments. Firstly, because there's lots of interconnected hardware and software components providing different functions, sharing different dependencies. And being able to take real-time information from all of those different levels and different components means gaining data from multiple data sources, and that generates a large amount of data. You need to be able to have the right data and storage tools to be able to give you a real-time verdict on what's happening. And lastly, legacy tools weren't built for this type of environment, and many of the frameworks that have historically been available require customization before you can get to a point where you can deliver the right level of monitoring and analysis in a cloud environment.
With Platformix software, you can gain visibility across different layers of the cloud infrastructure, from physical devices, routers, switches and servers, to the software-defined infrastructure operating in the cloud, public cloud instances, but also some of the applications and services that make up cloud-native applications. Platformix is more than just a monitoring software, so we're taking real-time telemetry data from all of these different layers and different endpoints, mapping dependencies between them, but also we're exposing functionality out of the box that allows you to use that data in a meaningful way and operate the cloud in a much more efficient, cost-effective and intent-driven way. The initial element of that is being able to forecast resource usage more accurately. So actually looking at the capacity of the cloud infrastructure, understanding based on what has been used, what's likely to be used in the future. And this gives you a much more accurate view based on historical data to be able to plan and cost in any infrastructure changes that you need to make. But also because we're taking that real-time information, as I talked about earlier on, we can monitor the health of all of these different resources and check the status of that health in relation to a defined service level agreement. And if that service level agreement is at risk of being breached or is breached, Platformix has the possibility to signal other orchestrators to take actions to try and remedy that. And we'll talk about that a bit more in a minute. Additionally, you can visualize alarms and monitor these resources per tenant. So it's possible to expose some of this detail to your customers and enhance the service you're providing to them. But also, Platformix doesn't just look at arbitrary thresholds like I discussed earlier on. You can actually ask it to learn about the behavior of the cloud environment, and then if that behavior deviates after it's learnt, it can indicate that there's a deviation and therefore again put you in a position to take remedial action. And the last aspect of this functionality is per tenant billing and reporting. So actually you have the capability as a cloud operator to help the customers visualize what they're using, but also per customer you can specify different charging mechanisms for different cloud resources, for compute, storage, networking, for example. Let's take a closer look at the resource orchestration closed-loop automation within Platformix. So on the left-hand side, you can see that we have distributed agents out on the endpoints that we're monitoring, so in this case, bare metal servers. And what we have within that is a policy that makes sure that we're defining at source the things that we're interested in and things that we want to send back to the Platformix controller. and we stream that data back in real time. And doing that source-based policy allows us to get the meaningful data out quickly in a distributed way and inform the app performance controller so that you've got the real-time data to use those functions and features that I talked about. In the case of resource orchestration, that means you've got enough time to look at the health of a resource or a group of resources and understand if that meets a given SLA that's predefined. And if it's not, you can set a policy to inform other endpoints, in this case OpenStack, to do something, potentially move a virtual machine from a global operations perspective to remedy that situation and maintain the service assurance that you're providing to the customer. But those endpoints themselves can be any HTTPS endpoint, so that could be any network automation system or controller that is capable of receiving that notification. We'll also send notifications to incident management systems and collaboration tools. So let's come back to security now and look at how we can apply some of the principles I've just been talking about from a security standpoint. Cloud providers absorb a lot of risk on behalf of their customers, not only in securing the underlying cloud infrastructure, but in a lot of cases providing additional security services to the end customers. And as I discussed at the start of the call, this is being provided across multiple different domains, trying to protect different types of workloads, different endpoints, and also using multiple tools to look at each and every one of those environments or even different stages of the threat lifecycle. So from an operational complexity perspective, it makes it very difficult to implement consistent policy, which we've talked about using Contrail to improve that, but also the ability and the time it takes to mitigate a threat from the time a new threat is detected, but not only just mitigate it, but update cross tools and environments to understand and share that threat intelligence and make sure that the entire network is protected. So what we've discussed already on the call is just the impact of having to manage multiple domains in different clouds, different infrastructures, different vendors. And actually what we see in the industry is lots of environments and lots of tools used to monitor those environments and the security state of them. So this generates a lot of data, and we see that security operations, more often than not, are having to look back after the fact and taking a lot of time to do the necessary correlation and analysis before even being able to identify that there's a problem and then take an action. Juniper created a unified cybersecurity platform, and that uses open APIs to ingest threat intelligence to give a much broader view of these environments and also automatically share that with other systems. Also, within this is an automation layer that allows operators to predefine in policy what actions they'd like to take to respond to a certain level of threat. For example, if a host machine or virtual machine is known to have become infected with a virus or is therefore gone out of compliance, then quarantine it. And we're allowing this enforcement to occur in private and public clouds, on multi-vendor virtual resources, physical firewalls, endpoints, and even on physical switchboards. So ultimately, this reduces the time taken to identify and respond to threats and actually minimizes security admin because it removes the need for manual analysis and gets results to operators a lot quicker. And as I talked about, potentially even for common actions and known behaviors, taking an automated action to remedy the problem. So I'll walk you through some of the key features that enable us to do this. And the first step is discovery of those resources and the policy across clouds, and using data about those resources to be used in a centralized single policy set and define the desired security behavior within that. Once you have that state and you have that awareness, you can monitor for threats. And this is where we use artificial intelligence and machine learning to dynamically identify threats to these environments over time. And as I spoke about earlier, providing a much faster risk analysis on threats and identification of impacted resources than a human operator can provide. So once that threat and any infected resources have been identified, this is where the predefined actions can be implemented using the automation layer of the platform. And that just allows a lot faster mitigation. And as I mentioned, that mitigation can be carried out across the entire network. So we're providing greater protection to contain and stop the spread of malware, even if it's already past the perimeter or has been introduced internally even. So the final step is sharing that updated threat intelligence. So once you've been through the cycle, you understand that there's a new threat, you've mitigated that, you need to inform other systems about that so necessary actions can be taken and you can protect against that threat elsewhere. So we can inform other systems about it and ensure that the entire security ecosystem is fully synced and aware of the latest threats. So what you can see is, as a cycle and as a piece of software, we're much reducing the operational effort required to administer a multi-cloud environment, but also multi-vendor systems, and being able to, as a cloud operator, provide a much more dynamic and secure way of protecting your customers and offering them security services. Looking more at those operational aspects, what we're actually doing is using a single centralized management platform to gain visibility into the security state of different cloud environments. So that's public clouds as well as our own Contrail system. It also includes physical resources in the data center as well as VMware NSX. So that's providing us actionable intelligence across cloud boundaries and actually reduces the effort and the operational cost to manage these different environments, particularly from a cloud operator's perspective, having to then onwardly deliver a service to their customers. But additionally, what we're doing here is, having been able to discover that level of policy across these domains, is we're able to combine that into a single policy set. So we're greatly reducing the administration overhead, resulting in having to administer security across these different environments. And because we're using endpoint metadata instead of traditional IP constructs like IP addresses, then we can actually make sure that that policy is portable and can cope with the dynamic nature of the cloud. Overall, what we're doing here is looking to reduce operational complexity that comes from managing security and responding to threats across these environments. So that concludes my section on 3 simple strategies to reduce operational complexity in a multi-cloud environment. And what I'd like to do now is hand over to Kevin Fibich of CloudSeeds.
Thanks, Ben. So I'd like to start with a brief introduction of CloudSeeds as a company and what we're doing and why that's very relevant to the topic today. I founded CloudSeeds in January 2013 as a company to build an open source based turnkey private cloud model. As in my work in basically the early days of cloud computing, we observed that a lot of companies build very similar infrastructures from scratch, which are not as optimized as they could be, and there was actually a market for something more turnkey. So upon this idea, we started building a flexible and scalable, secure private cloud platform, and that is basically the foundation of this company. We're located in Hamburg, and we have been around, as I said, since 2013, which is quite a long time measured in the total history of cloud computing. And during that time, we observed quite a bit of new trends and shifts in the market, and which brings me to my next slide about what we're currently doing today. So the internet has seen quite a lot of evolutions throughout its history, and those evolutions have been mainly driven by new services that gained popularity. As the internet started out basically with static websites, and then we had the first big evolution with Web 2.0 and user-generated content. The next one was very much the smartphones and mobile applications, and we currently see that we're at another brink of such an evolution of the internet, with new applications primarily being virtual reality, augmented reality, and in general remote rendering or remote gaming. Because these services have requirements, of course, towards bandwidth. They need quite a lot of that. But they also have requirements towards latency, and they require very low latency, and also they require low jitter. And the current architecture of the networks comprising the internet is not really optimal for these types of services. So we see that there needs to be a new architecture, a new shift, a new evolution of these future networks to really bring these services in an enjoyable manner to the end users. And one of the biggest changes basically that we need is a shift away from centralized data center locations more to distributed or more to edge computing use cases to really be able to get to that required level of latency. But also the second thing that of course drives the internet is growth, and we see quite a lot of that will be happening, especially with IoT. Is predicted that the amount of devices that will connect to the internet will grow quite dramatically through basically every little device, every household item getting a Wi-Fi connection and starting to talk to services, which is what we know under IoT. And maybe the third thing is also the evolution of the mobile networks with 5G. Those will require quite a lot of new architectural elements to the networks, and also telco cloud, which is virtualizing and really leveraging VNF to build new more dynamic and higher performance networks that can adapt faster to those changing requirements. To meet these new requirements, services need to move closer to the consumers, which we can do with edge computing. But computing at the edge of our network also has drawbacks, so it's not suitable for every service we want to present. That's why our approach is to transform the whole network from being a tool to transport the services into the service network, a network in which every location can run services. This network is highly automated, operates intent-based, and can even interact with the services it's providing. Essentially, the whole network becomes a distributed cloud. Many modern complex services are segmented into so-called microservices, and each of these microservices has different characteristics and requirements. For each microservice, there is an optimal topological or even geographical location within our service network to run that microservice while optimally serving its requirements. Since the service network is fully automated and able to interact with the services it is running, the service network can not only maintain its own health and integrity, but is able to move and redeploy these microservices to new locations if something changes or a better suited location is being found. For us to be able to achieve this vision of the service network, it takes a huge amount of cutting-edge tools and technology. Most importantly, a reliable, resilient network covering multiple geographical locations is required and becomes integral to the services being provided. This is where Juniper Networks hardware has really made a difference. Nowhere else did we find such flexibility, and Junos made automating and orchestrating the physical parts of the service network way easier than we expected. Also, Contrail is a big part of making this concept even feasible. Only by extracting the network and dealing with the service requirements in the software-defined overlay layer are we even able to span the service networks across any given location, which is a must. And to design the network intent-based, lots of metrics and monitoring data from all components across all layers needs to be generated, analyzed, and then fed back into the loop to create this continuum of self-optimization and self-management, essentially. This is quite the challenge, and AppFormic's unique concept to doing this helps really in doing that at scale and being able to provide a system that can dynamically scale to big dimensions. Well, also separating the network into over and underlay had quite the implications for security, and dealing with security has become quite a bit easier in the underlay, as it's essentially isolated from the outside world. But it has moved the security concerns for the services to the overlay, or the virtual layer, where traditional security methods are not feasible, or at least not optimal, to deal with these threats. This is where new solutions are necessary, and contract security seems to fit quite nicely, as it's designed around multi-cloud environments with intent-driven policies and integrates perfectly with the orchestration tools we are using, specifically OpenStack and Kubernetes. Another very interesting aspect to us is using dynamic interaction with application data and machine learning technology to detect threats. Yeah, so it has been quite the pleasurable experience working with Juniper, and I guess this concludes our experiences. So back to you, Steve.
Thanks, Kevin. Let's say thanks to both yourself and Ben for running us through your thoughts on this webinar. Before we start the Q&A, I'd like to recap the 3 simple strategies. As you can see, the 3 strategies are around, firstly, orchestration, secondly, analytics, and third, security. Each of these areas have their own complex challenges that need to be overcome to deliver operational simplicity. You could try to build a single software stack that covered all 3 of these, but if you went down that road, there's a risk that it would take too long to develop. Instead, I suggest you want to focus on each of these 3 separately. There are overlaps between the 3, but if each of them is delivered in a world-class way, it will enable your business to remove significant amounts of operational complexity. My summary of the content is that to do this, you need to focus upon the ideas of automated, multi-vendor, and open standards, with each of these 3 areas of orchestration, analytics, and security.
That concludes the pre-prepared content for this webinar. We'll move to the Q&A part of the webinar now. But before we do that, I'd like to draw your attention to the link on the current slide, which will take you to a site that contains further reading and case studies on the topics discussed today. Please submit your questions via the web interface, and we will answer them as soon as they come in. Hi, everybody. So we've got some questions that have come in, and the first one I'd like to ask Kevin to answer. And the question is around how did you have to change any of your areas of the culture in your business to achieve these levels of automation? So Kevin, over to you.
Yeah, so with our company, we said there in the beginning when we founded the company, and we said that we wanted automation really to be one of the defining points of our work. So for us, we immediately started this at the get-go. But we have seen with a lot of our customers that did not have this initial idea of doing this automation, that they had quite more struggles, and they operated a bit differently and had a different culture, because this level of automation, this style of working and operating, it requires a different culture. Yeah, so I can say that definitely it's, for example, you really have to embrace this openness in your work, because if you don't do something on your CLI on a system or something, but instead build something that does it automatically, and you use like source code repositories, etc., your work becomes very transparent. Everybody in the team can see all the details of what you have done and what you have created, and this can lead to a lot of discussion, and this transparency. Not everybody feels immediately familiar or even okay with it. So that's something that requires quite a shift in culture to work with something like that.
Thanks for having answer, Kevin. It's also reminded of sort of working with some customers that I've been with, where that change of culture also requires quite often a big step change occasion in the business where you decide this is going to happen. I guess in your case, being a startup, it sort of happens from day one, but in a more established business, it's a trickier one to do. I just want to remind everyone, if you want to submit any questions, use the Q&A window within the interface, and we'll answer them. So there's another one I'd like to this time put to Ben. This was around one of the solutions to complexity reduction, the universal network transport technologies such as MPLS that can unify data center core access and aggregation, etc., and then allow one overlay using SDN to have a coherent policy for automation, security, etc., etc. So I'll hand that one over to you, Ben, to give some of your thoughts.
Okay, so I'm reading that as a kind of pure transport connectivity question. So the different domains between data centers and out to access navigation and even some of the core networking. So actually, that's probably a more plausible concept now because there's a lot more commonality in the way that MPLS is being rolled out there in terms of right to the edge. So it's definitely plausible. I think what we have been concentrating on, particularly with Contrail, is the cloud and data center focused use cases, but we are enabling a workflow for data center interconnection within that. I think what we see is we don't have every customer operating in every one of those domains, although many of you on the call may be doing that. So what I'd probably see is it more as a plug-in architecture and us evolving to that, where there'll be a platform that you can pick and choose which domain you need that provisioning to go across. But certainly, yes, I would agree that could certainly reduce a lot of complexity, and I think that's something we're aware of. Probably worth mentioning a little bit as well is one of the ways that we are able to kind of blend between different domains is using API interaction between different tools. So a lot of the AppFormix that I just talked about, that capability is going to be integrated into the Contrail platform, but we've also recently shown a different use case for AppFormix in identifying grey failures on the network early and then notifying our transport SDN controller Northstar to reroute MPLS services around that. So that's also a slightly separate use case. But so we do have some element of API integration across that and the possibility to orchestrate across the multiple domains. But certainly going forward, I think you'll see, at least from an access navigation and core and maybe even DCI, more of a kind of plug-in or opt-in type of platform going forward. Hopefully that answers the question.
Cool, thanks. Yeah, thanks for that, Ben. I guess the question to either Ben or Kevin, what do you see for the role for SD-WAN within the sort of area of cloud providers and how it fits with the existing visit? Is it sort of complementary or a separate area? So good to get some of your thoughts on that.
I'll take that one first. So I've actually seen people looking to use SD-WAN and so be able to classify and forward decisions based on application when they've actually been starting in the public cloud. And so they're kind of doing a over-the-top connectivity into infrastructure that they've launched out in public cloud themselves, so they're able to control that. So that's one of the use cases I've seen. But certainly in UK and Europe, services that our typical kind of NSPs or cloud service providers, if you like, provide, tend to incorporate the network as well. So certainly if they're providing some level of edge access and want to be able to provide customers with that differentiation between different applications going to different areas that they provide. So a good one would be, if they're using the network to connect them to private services within their own data center and to SaaS or public cloud, actually being able to route based on application. Now, not necessarily from a cost perspective in our market, as you might see out in the US, where there's a really big difference between the cost of access of MPLS and ADSL, but possibly for quality of experience. That's the use case, really. I don't know if you've got...
Cool, thanks, Ben. Just quick. Anything you want to add to that, Kevin? I'll move on to the next question. Just remember you can input any. So just remember you can input any other questions if anyone has got any through the window. We've had one other for Kevin, and this is: where have you seen the greatest challenge for operations within the orchestration, the analytics, or the security domain?
Well, that's kind of a tricky question because operations is a constant evolution if you progress in automation and in orchestration. So at first, orchestration is the real challenge. But once you overcome that challenge and bring more and more orchestration and more automation into your system, at that point, analytics becomes the next great challenge. And again, our security and analytics basically at the same time, because you definitely need analytics for your security in there. So they are all great challenges, but as I see it, orchestration is the first greatest challenge. And once you got that, once you progress on that, the other ones become the next greatest ones.
Cool, thanks for that, Kevin. I guess we've got time for one or two more questions. So I've got one which I think is probably for Ben to answer, which is around, will you be able to automate the creation of encrypted connections from the private data center to the VPC gateway in AWS? So over to Ben for that one. Ben, did you get that question?
Yep, sorry about that. So, yeah, the workflows that we'll be exposing in Contrail will allow you to do that. Yeah, so we'll be able to discover VPC in AWS, and actually there'll be a number of options to be able to create encrypted connection over the internet. And we'll also be looking to support the direct connectivity just using BGP, and again, providing a workflow that delivers that as well.
Okay, Ben, thanks for that answer. So I haven't had any more questions come in, so I think we're getting towards the end of the allotted time for this webinar. So I'd like to thank everyone for joining. You'll all get an email with a replay link. There is a link to the slides on the screen as well, and you can always get these back at any other time. If there's any other colleagues that haven't joined this, you think the interest for them, you'll be able to forward those links onto them and they'll be able to register to watch it. So first of all, thanks to both Kevin and Ben for joining us on this webinar today and sharing their expertise, and to all of the audience for attending. So thank you very much, everybody.